so how do I solve a polynomial inequality by graphing? Well, the first thing I need to do is I need to be able to sketch it. So number one, you're going to just try to sketch it. So we're going to skip example A, but we're going to work on part B. Okay, so I want to sketch it. So let's look at the end behavior. I'm going to abbreviate that as EB. If I multiply the x squared times the x squared, I'm going to get my leading term to be the x to the fourth. And I can tell that's going to be the leading term because this has the highest exponent and that has the highest exponent. And when you multiply, if I were to distribute everything, the leading term would come from the two terms that had the highest exponent in the first place. So x squared times x squared is x to the fourth. The degree is even, leading coefficient is positive, so both ends are going to point up. All right, now let's keep factoring it to figure out the other information. So x squared plus 1, I'm just going to need all this space. So x squared minus 1 will factor into x plus 1 times x minus 1. And then x squared minus x minus 6, x and x. Let's see, to get negative 6, I could do minus 3 and plus 2 greater than 0. Okay, now I can't apply the zero product property to an inequality because the zero product property only works when you have an equal 0. So that's why you need to solve these by sketching. Don't just set each one greater than 0. That's not going to work. We need to sketch this. So I have x-intercepts at negative 1, positive 1, positive 3, and negative 2. And I'm getting that from these numbers right here. You take the opposite because you would set each one equal to 0 to find the x-intercepts. So sketch negative 1, 1, negative 2, 3. X-intercept here, x-intercept there, x-intercept here, x-intercept there. Both ends point up. Let's see, all the multiplicity looks odd because none of these x-intercepts repeat. So I'm going to cross, 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 cross. And the y-intercept, if I let the x equal 0, so if I take this original equation and let x equal 0, I would have 0 squared minus 1 times 0 squared minus 0 minus 6 be the y. So negative 1 times negative 6 would be positive 6. So y-intercept would be at 0, 6. Okay, so cross, 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 cross. Yay, I sketched it. Now, how do I find the answer? Well, let's get a different highlighter so I can show you what I'm talking about. Okay, so the question asks, when is the inequality greater than 0? Another way to say greater than 0 is positive. So this is asking me, when is this graph positive? Graph is positive when it's above the x-axis. So right here, and right here. So then my solution would be everything from negative infinity to negative 2 in union with negative 1 to 1, everything in between 1 and negative 1 and 1, and then from 3 to infinity. All the places where my graph would be positive. All right, now let's do a word problem. We're going back up to example 4. We're going out of order today, but I think this is the way that makes the most sense. All right, so Acme Innovations makes and sells lamps. Now this information right here is information that would have been printed in your book or that I would have given you. So you might want to add it into your notes just so that you'll have a little bit more information so that your notes will make a little more sense. But the part that they left out is that these two sentences up here. Acme Innovations makes and sells lamps. Their profit B in hundreds of dollars earned is a function of the number of lamps sold X in thousands. Due to an increase in the cost of materials, the profit function for Acme Innovations has changed to Q of X equals negative X cubed plus 10X squared plus 13X minus 22. How many lamps should they make in order to make a profit? So how many lamps? I'm going to highlight that. Well, we know that lamps, let's go up here. What did they say? Number of lamps sold X. Okay. X, that's lamps. So they want to know how many X's. And remember, X is in thousands. We'll have to come back to that. In order to make a profit. So we have this function Q of X for profit. You make a profit when that profit is greater than 0. So when Q of X is greater than 0, in other words, another way to say that is positive. Okay, so let's grab Desmos. All right, and I'm going to type in that Q of X function, negative X to the third plus 10X squared plus 13X minus 22. Okay, and then I'm going to zoom out. Ooh, looks like this is quite a lot. Okay, so I want to know when it's going to be positive. Now I see this graph is really skinny, and I can like pull this way and zoom it in, or if I'm squeezing with my 2 fingers and pulling out. But if your computer doesn't do that, you can click on that wrench and change the x-axis values so that you see a different scale on the x-axis. So I'm interested in when is the company going to make a profit. So profit is the y-axis. So when is the graph positive on the y-axis? Well, it's positive like before this x-intercept negative 2, 0, but remember x is the number of lamps, and you can't make negative number of lamps. So I'm not interested in anything to the left of the y-axis. So I'm just going to scoot that part over. I'm only interested in this part. So at first the graph is negative until you get to this point right here, 1. And then it's positive, positive, positive until you get to 11. So the company makes a profit when they sell between more than 1, but fewer than 11. And this is, remember, X is in thousands? Yes, in thousands of lamps. So the company makes a profit when they make more than 1,000 lamps, but less than 11,000 lamps, because maybe they start charging too much, or maybe the cost of production gets too high, but they only make a profit between those 2 values. So let's add that back to our notes. When do they make a profit? They make a profit when they sell, or nope, because the question is when they should make. When they make more than 1,000 but less than 11,000 lamps. Done. That was quick. All right, next question, and this is the last one. Now we're going to talk about solving polynomial equations. The way that you solve a polynomial equation, or the way that you want to try to solve it, is you want to solve by factoring. So when you're solving by factoring, the first thing you have to do is you have to set it equal to 0. So I'm going to take example A, and I'm going to set it equal to 0. Yes. So I'm going to subtract the x cubed. Oh, that's nice. It cancels. I'm going to add the 7x to the like terms. And then I'm going to subtract the 6 from the like terms. So it looks like my equation will be 0 equals 5x squared plus 5x minus 30. And then I'm going to solve. So let's see, 5x squared, 5x, and 30, they have a greatest common factor of 5. So let me factor out the 5 first. Then I'm going to factor, so 0 equals 5. I see that it's a trinomial. When you have a trinomial, you try to divide it into 2 binomials and factor. Let's see, two numbers that multiply to be -6 and combine to be positive x would be a plus 3 and a minus 2. And then if I set it equal to, each factor equal to 0, I'll have my solution. Solutions. So 0 does not equal 5, x equals -3, and x equals 2. Those are my solutions. Now here's a nice hint. You see how many solutions I have? 1, 2. You see the degree of the equation that once it was set equal to 0 was 2? Whatever the degree is, that's how many solutions you can have. You may have that number, you may have fewer than that number, but you will have that many solutions. All right, part B, let's try this one. Part B, a little bit more interesting. Let's set it equal to 0, so I'm going to add the x cubed. There's no like terms on the left side, so you'll see what happens, and add the 2x. So I'll have x to the 4th plus x cubed plus 2x squared plus 2x equals 0. Now I have 1, 2, 3, 4 terms. If there are 4 terms, you want to try that grouping method. And that's where you group the first 2 terms and the second 2 terms, and you factor out the greatest common factor from each group. The greatest common factor in the first group is an x squared. Greatest common factor in the second group is a positive 2x. If I factor an x squared out of the first group, I'll be left with x squared. No, not x. Yeah, x squared. Oh no, I can factor out an x cubed from the first group. So then if I factor out an x cubed from the first group, I'll be left with an x plus 1. And then if I factor out a 2x from the second group, I'll be left with an x plus 1. Then I'll bring down my equal 0. Now notice both groups have an x plus 1, so I'm going to factor out that x plus 1. That leaves me with an x cubed plus 2x equals 0. And then with the x cubed plus 2x, I noticed there's a greatest common factor in there, so I could factor out an x from that group. So bring down the x plus 1, factor out an x, and x squared plus 2. So now I can apply the zero product property. Set each factor equal to 0. So if I set x plus 1 equal to 0, one solution is going to be -1. Done. If you set x equal to 0, there's a solution. If I set the x squared plus 2 equal to 0, I'll have x squared equals -2. Take the square root of both sides. X is plus or minus the square root of -1 times 2. Square root of -1 is I. So x is going to be plus or minus I square root of 2. So let's see. What was the degree on the original equation, or when it was set equal to 0? The degree when it was set equal to 0 was 4. So I should have up to 4 solutions. 1, 2, and then this plus would be one solution, 3, 4. So 4 solutions all together.